Alright, so this is lesson 4. We're going to talk about paths and sensors, at least the basic sensors that we would use for building scenarios. And then maybe the next lesson will be all the other types of sensors that we typically use, um, such as putting up images for turn instructions and scenario control type sensors. So here is our lesson, our database that we've been working on. And let me kind of zoom out here a little bit. And so we're going to build a basic scenario. And so what I've gone ahead and done before I started capturing video here is I've built a basic construction zone. So we're going to do a path intrusion scenario. So we've got a parking lot over here. Our driver is going to be coming up this way, and we're just going to have a car pull out in front of him. And so I put in this construction zone to kind of act as kind of a distractor, perhaps, for the driver. And where I got these, so these objects, I'll just quickly show you. So we'll zoom in, and we'll go back to walk mode. So these boxes here are actually under military objects right here, and you can actually retexture these to be either blue or orange. You can also retexture them to be other things as well. Sometimes you can get lucky and find a texture that looks halfway decent. I know there's a tent in here somewhere that actually works well on this, a tent texture. Um, it's not really important, but what I do want to show you is where, after, so we have a lot of filler tiles here. And one important thing to know is that even though you've put filler tiles in the database, you can still add objects to them, and it will put those objects on the tile that you have placed down. So even though it's frozen, it'll still make those things that you drop onto it. So if I were to drop on this porta potty here, there's our military toilet in the middle of the roadway. And I don't really bother with freezing everything. You can, I suppose, go through and freeze all these. Um, it's really not that big a deal, I think, because they're small objects. The real problem, the reason why you want to freeze these underlying tiles is because they're so big and easy to accidentally select without realizing it, because the borders of the bounding box will be off your screen and you wouldn't be able to tell that you even have it selected. The only clue that would be that this over here it would turn red. So just as an example, let's add a final feature to our scenario here. We're going to add a tree wall to this, and we're going to reduce its size down so that it's not huge like this, but reduce it so that, let me back off so I can actually see what I'm doing. Alright, come on, you. I'm sorry, my thing's not cooperating here. Get back, go back. Alright. Tree wall. So it's right here. We put just, you can see the border of the tile right there. So it's just over the border, so it's a child of that tile, which is this one. And if we, why isn't it moving? Move. Okay, for some reason it's not allowing me to grab it and move it. Okay, fine. Be that way. Delete. Let's try again. Okay, there we go. So let's shrink it, and when we shrink it, we'll rescale it down to say 0.3, and maybe make it a little bit taller, 0.6. Now it looks more like a shrub, some shrubs or bushes. And then we can stick a small shrub at the end, a small tree. Nice thing about trees is if you reduce them and sink them into the ground, they look like bushes. Okay, so that's going to mask our car moving in the parking lot. This tree wall. All right, so we've got the physical attributes of our scenario ready. So now we're ready to start putting in our sensors and paths. So let's first talk about paths. So first thing we have to do is tell the computer where to start our driver. So let's actually have our driver start here. So our driver is going to go around this figure 8 and go through our four-way intersection and meet our parking lot, our driver somewhere up there, or our path intrusion vehicle up there. So under scenario control is where all your sensors and everything are located. And the start point is over here. And if you drag it on, you'll see a little red car show up on the screen. And you'll see the car has an orientation. Now the orientation of that vehicle will be the orientation of your subject when the scenario starts. So you'll want to rotate it. And again, it's clockwise, so it's -90. And place it in the lane where you want it to be. So that's exactly where our driver will start. Now you can start a database without having a start point, except the default is the origin. So if we come up here and look at 0, 0, our driver would start right in the middle of that four-way intersection. So that's, if there's no start point, your driver starts at 0, 0. All right, so here's where, then again, now that we're beginning to place sensors and paths, we get into housekeeping again. And the housekeeping is basically just our term for how we organize our database. And we should keep our geometry, which would be our tiles and features, buildings and trees and so on, separate from our sensors. So, we've got this group here called block roadway tiles. And every time we drop a sensor in, we're going to move it, or a path, and we're going to move it out. And a start point really is kind of a sensor. So we're going to create a new group called block sensors. And block meaning just, we have a tendency to call our drives blocks in the lab. And then we might have another group, one here just for our start point. And if we have if we put in a sensor that we attach code to that we want to start at the beginning of the drive, we might drop it into this group right here with the start point. But we don't have that yet. All right, so now we've got our start point established, so let's go back to our scenario. And the first thing we're going to do is let's just talk through the scenario. So we need a couple things. We need a vehicle to come out right here and maybe turn left and join this roadway. And we need some kind of trigger point for that. So that's going to be a sensor that we put in. And so let's do the first part, which is put in the path for our vehicle, for our path intrusion vehicle. So down here we've got paths and we've got path targets. So the path is basically a pylon that's the starting point for a vehicle that you want to script and put in your database. So let's drag in a path and we'll start it somewhere in the parking lot. And you'll, again, just like with other sensors, the vehicle, you see a little arrow here on the ground, that'll be the starting orientation of the vehicle that you're putting in. And I use the term vehicle. You can also use paths for actors, which is their term for pedestrians. So pedestrians and vehicles use paths. But I'm just going to use the term vehicle at this point. So that's your orientation, your starting orientation of your vehicle that you're going to drop in. So we want it facing the other way, so we're going to rotate this 180 degrees. And we want to drag this out because we're going to create a new group for our block paths. So block paths. Again, it's very important that you do this as you go. You organize as you go. You will thank yourself, and your lab mates will thank you in the future. The next poor sap who has to decode your stuff will really appreciate how organized that you are, and will make it much easier for them to decipher how you did things. So with paths, we can put another subgroup here underneath block paths. And let's call this like scenario 1, or scenario 1 paths. So we've got a group here called scenario 1 paths. So now we're only going to have one path because we're only going to have one vehicle. We could let's make another vehicle. We'll put in a second vehicle up here somewhere doing something else. And so you have to give your paths a name. So you come over here to your hierarchy, and typically I leave the term path on there, but then I put in the scenario. And again, I use very verbose language in the path names. So path, scenario 1, intrusion, vehicle. So or let's call it the conflict vehicle. Okay, and here when I put in VEH, another thing I like to do, and this will actually be very helpful to you, is over here taped to the edge of the simulator is a list. It's an array that is in the database model, and you can see here there's vehicle 0, and I'm sorry that you cannot see this on the video, but if you just look to your right, there's a list here, vehicle 0 through 39, and then there's a path that in the file name is description of the vehicle. So you've got, like vehicle 1 is a VW Passat, a green VW Passat. Then vehicles 2 through 5 are BMWs of various colors. The DAF 65 is a box truck. If you just go through, there's a police cruiser in there. There's various SUVs. There's I believe a bus in there as well. So those are the vehicle numbers. So what I like to do, if I keep a list I print out a list of all the vehicles 0 through 39, and as I use them I cross them off, because if you reuse a vehicle number it can cause problems because if you move it, if you don't keep track of what vehicles you've used, you'll accidentally use one twice, and you'll be confused as to why the vehicle that you want doesn't show up where it's supposed to. So let's just pick a vehicle. Let's have vehicle, I don't know, 28, this blue Peugeot 306. So that's vehicle 28. So I type in, as part of the path name, I type in the vehicle number. And then another thing that you'll notice here, that even though we've changed the path name here, it still just says path right there. You want to be able to see in your database your full path name. That helps with debugging later on. So what you can do to change that label is just copy this to your clipboard, go up to properties, and here under label is that text. And you just paste it there, hit return, and boom, there's your full path name. Again, highly recommend that you do that. Now, so that's just your starting point of your path. Now we need to put in the path targets, or path targets. And so over here we've got our path targets. We just start dropping those in, and the path is the path the vehicle will take until it reaches the end of that path. So here, if we're going to have it turn left, we might put in, a curve here, and then I'm going to move around so we can see and line it up with the middle of the lane. So let's have it turn sharply here, and then end in the middle. Okay, now does this mean that our vehicle is going to travel this path and stop? No. What this is embedded in all of these models are roadway information. So vehicles traveling on these roads in the database, once they find the center of a lane, they can travel in that lane. But you have to get them there if they're starting from somewhere off the roadway. And you can do one of two things with vehicles. You can have them either traverse stop, which means they travel the path that you give them and stop at the end. And you might do that for cars pulling into a driveway, cars pulling into a parking spot, cars suddenly stopping like a emergency stop, or pedestrians might walk a path and stop as well. You can also have them traverse join, which is what we're going to do, which means they traverse the path, and then they drive over the last marker or path target, and they just join the roadway and begin behaving normally. And so that's what we're going to do here. We're going to do a traverse join, and you do that with code. We'll do that. We'll do that a little bit later with and that's the code is what you attach to the sensor. All right, so now we can see here. One thing we want to do is our path targets. We want to make them children of our path itself. So you can see over here, and I should have done this as I went along, but we just drag those to our path and we drop them in. And you want to put them the order that they are listed under the path is the order that they'll visit. So you always want to kind of check to make sure that they're in the right sequence under there. Otherwise, if they're out of sequence, you'll have your car will travel to this one, do a complete 180, go back, visit the previous one, do another 180, and go. It'll act really crazy. Okay, so we're done with that path. So we've established we've got a path to get our vehicle from the parking lot where there is no lane information to the middle of a lane, a target lane. So let's start another vehicle over here, just for giggles. And this is what you might do when you're starting a car in the middle of a lane. So here we're going to drop in a path, and we're going to drag that to our scenario 1 paths, and then we'll rotate it. Yep, we need to go the other way, 180. Alright, so if you can see the word path, that means the car is going away from you, this direction. So we'll call this scenario 1 oncoming vehicle, and let's pick a number. Always again put your vehicle number. So let's use vehicle number 3, which is a green BMW. So I'll just put vehicle 3 there. I'm going to copy that, go up to properties, change my label, and now let's start dropping it. Let's drop in a path target. Now since we're already starting in the middle of the lane, you really only need one path target, because what we're going to do is we're going to have it traverse join. So, and that path target can actually be very close to our path pylon. We'll drag that to our path, and we're done with that one. So we're actually done putting in our paths. We've got our descriptive, our verbose path names, and that's helps with debugging later on if there are issues. It also, by putting the vehicle ID number in, it helps us keep track of what vehicles we've used, and when we're writing the code, it's a reference we can use to help us remember what vehicle we wanted to use as well, because we haven't written the code yet. So now we need we might need two sensors to start our vehicles. So let's put in one sensor to start the oncoming vehicle, vehicle 3, and let's put it right here. So we've got various sensors here, and I'll just drop in a couple, and they're more or less the same except they're different shapes. They do have slightly different properties. The type I recommend you use, and the type I use almost exclusively is the box-shaped sensor. This one here. Sometimes there's also a plain sensor as well that you could possibly use, but it doesn't have an exit feature. So if you can have vehicles, you can execute code either on entry to the sensor, on exit from the sensor, also on initialization when the simulation starts. You can attach code for that as well. So what I like to do with my sensors, and again we've got first thing we should do is our housekeeping. So we've got this proximity sensor. One way you notice our hierarchy is beginning to get kind of full. It makes it a little bit harder to drag things to the root of the hierarchy. So another way of accomplishing the same thing is if you come up here to owner and pull that down, if you just go up and say none, it pops it out and has no owner now. It's in the root, like the root directory. So we're going to create a new group. We're going to call that our block sensors. And we'll do this. Oh, I must have used a space. You can't use spaces. It doesn't like spaces. So block. Oh, I'm sorry. I've already got a group called block sensors. My bad. Thanks. So actually, just delete that one. So we've got block sensors group already. So I'll create a new subgroup, and we'll call that scenario 1 sensors. Now with sensors, sensors cannot have children, so you can't have one sensor be the child of another sensor. That will cause the database to crash. So they always have to be kind of solo or on their own. But you can have them at different levels of the hierarchy in your groups here, but they can't have one sensor be the child of another one. So again, let's give this a descriptive name. So scenario 1, start oncoming vehicle 3. And again, we will change our label to match. And I like to see, so you want to resize this so that the vehicle will intersect it. The scaling I use a lot is to double the size, especially in the 4-lane roads. I double the size, and then I make it skinny using this, put it by making a Z of 1. And that's because sometimes you'll have sensors kind of closely packed together, and making it skinny this on this axis makes it easier to put in multiple sensors close to each other. You cannot have overlapping sensors. So box sensor. So this is okay. That's not okay. That will cause your database to crash. All right, and then finally, so now that we've got our sensor scaled up, and the reason why we scale it up is so that regardless of what lane our driver is in, they'll intersect that sensor. Then you'll want to bury the sensor a little bit, because the vehicle, the participant's vehicle, the simulator car, is actually just a point, defined as a point that travels about an inch above the ground, or less than an inch above the ground. So if you just drag a sensor in here and drop it, it's very possible that it actually might be slightly above the ground, and your car will literally drive underneath it and not intersect it. So what you do to prevent that from happening is you take your sensor and you just bury it slightly in the, about halfway in the ground. And I like to use the green arrow here as a reference point. So when that green arrow begins to disappear right there, I know I'm about halfway. So I stop just as it starts to dip below the roadway. So we've got our sensor, and what we will do is, and we'll do this later, but we will attach a piece of JavaScript to this, which is contained in its own separate file, .js suffix, and we come here and we attach it using this interface right here. But we'll do that a little bit later. Let's finish putting our other sensor in. So we also need a trigger for our conflict vehicle. So let's drop in another proximity sensor. Do our housekeeping. Always do your housekeeping. So scenario 1 sensors right there. Give it our descriptive name, scenario 1, start conflict vehicle 28, and change the label up here. So it's changed, we can see it. Change its shape, so scale it up, make it skinny, and bury it. And there we go. So that's good to go. So now we've got our sensor for that. So now we need to attach some code to those sensors. So right now this is not going to work as it is, because there's no programming code attached to these sensors, so nothing will happen. So let's go to our directory here. So if we go under databases, I gotta get my glasses on. Okay, databases, UMass, training. We're going to create a folder called scripts. That's where we're going to put our scripts. And the best way, because we do a lot of the same types of things, starting vehicles, really the best way to do this is just to go to other projects and steal the code from those projects. So I just was doing some work with Jingyi. So let's go to her scripts folder. You can see there's a whole mess of them here. So we want to start a vehicle. So this is another advantage of using verbose descriptive names. Just look up here and we'll find, okay, start drunk driver. That kind of sounds like what we want. And if we open it up, sure enough, we see the important code that we need to use. We've got this code here. In this section of the sensor, this function is onInitialize. So this will be executed. Anything in here will be executed when the database starts, the simulation starts. So this code scenario vehicle 3 move, and then the path name. That moves a vehicle to the beginning of to that pylon with that name. And then under on enter, this function executes when something enters it. And it's actually when anything enters it. So you have to use, if you want it to be exclusive to your subject or to another vehicle, you've got to use this if-then statement. So almost always you'll have some kind of if statement in here. So because our vehicle is going to be triggered by our subject, we can leave this alone, leave it as is subject, and then this code here, traverse command tells the vehicle to traverse this path, and then you can either traverse join or traverse stop. Now if I had traverse stop here instead of traverse join, the car would travel that path and stop at the end of it. Then this sets our velocity, and there's two ways you can do velocity. There's set velocity once, which basically makes the car instantly go that speed, and this is a conversion factor. The simulator actually uses meters per second. So if we want to type our speed in terms of miles per hour, you just use this predefined function and it converts it to meters per second so the simulator can use it. And then there's some other things we can do. We can set desired lane, and so once it drives off the end of the path, you can tell it to prefer either the left lane or the right lane. If you don't give it a desired lane, it'll be random. It'll just choose randomly. Same thing with desired turn. So we're going to, this right here, well anyway, with desired lane, it's lane leftmost or lane rightmost. With desired turn, what you're doing is you're compelling the car to do what to do at each intersection it encounters. So with this command, our vehicle will be compelled to turn left at every opportunity. So if you have a block, it'll just keep turning left and go around the block until you tell it otherwise, which is fine. Well, let's look at our data to see what would happen. So our vehicle would, if we have our, if we use that code for our conflict vehicle, we've already got it in the left lane, so we'll probably want to leave it there. But then it will come up to this intersection and turn left if we leave that alone. So let's actually change it to where it goes straight. And if you look in the manual, you'll find that you can either have turn left, turn right, or continue straight. Okay, so let's actually save this, save as, and we're going to save this so that we don't mess up Jingyi's stuff. In our training and scripts, and we're going to give this file name, we're going to make it the same as our sensor name. Makes it very easy to attach code later on. So scenario 1, start conflict vehicle 28, I believe it was. And so let me make sure it was, conflict vehicle 28. Yes, so and you'll notice here that that's the same scenario 1, start conflict vehicle 28. The reason why it's often handy to use the same name as as the sensor is that when you are debugging, it will tell you what JavaScript, the name of the JavaScript file that caused the problem. So usually it's a JavaScript error. If you use the same name, you make your JavaScript file the same name, the same as your sensor, you know what scenario got goofed up, what sensor it was, and everything. So it's very handy for debugging. So let's go back up here to our script and let's change it. So we're going to, this double slash is for comments. So this is actually a comment. So we're going to position our conflict vehicle. I do encourage you to comment your code. Vehicle 28. And we're going to change the, this, so that we're going to position vehicle 28 to path scenario 1, conflict vehicle 28. And you just want to double check to make sure that's the actual name that you gave it. So path scenario 1, conflict vehicle 28. So it's got to be able to find that path, and this the name here is what it'll look for. So whatever's typed there is where what's looking for. And entity is subject, so that makes that sensor exclusive to subject. So any other vehicle that enters that will not execute this code here. And then we're going to change all of these to vehicle 28. And we're going to change our traversed path.
Didn't say that.
What?
Didn't say that. It's still drunk driver.
Oh, I'm doing the wrong one. Oh, there it is. Okay. Sorry. I had two copies of the same file open. So, okay. And then copy that. And, let's have it go 40 miles per hour. And left lane is fine. We've already changed it to be continue straight, so we're pretty much done. It's going to traverse join, so it'll drive off the end of the path and join the roadway and begin behaving as we, based on these rules here. It's desired speed. Set velocity once makes the speed go instantly to 40. You can also say set desired velocity, and there's another. I'll show you an example of. Let's actually go grab a copy of. Let's go and find a copy of set desired velocity. So just so you know what that looks like, set desired velocity makes the vehicle go accelerate up to some speed. So extra. So here's an example of set desired velocity. So let's drop that in and just comment it out. So we could also have set vehicle 28 set desired velocity to 40, and you need this velocity fixed term in there. So if you use this term instead of set velocity once, it'll start at 0 and then slowly accelerate. Based on some default acceleration, it'll accelerate up to 40 rather than going instantly 40 miles per hour. So we'll comment that out so it doesn't actually suddenly you know what, actually, because it's coming out of a parking lot, it probably makes more sense for it to accelerate up. So let's actually comment out the set velocity once. We'll use set desired velocity instead of 40 miles per hour. That makes more sense. So now that we're done with our code, we're going to attach it to this sensor. So we're going to come over here, highlight our start conflict vehicle, come over here to user script, and we're going to open our scripts folder. And unfortunately, that .js suffix is not, file extension is not in the list, so you have to say all files to see it. Highlight it, and there you go. So now it's there. It puts in a relative path. Once you save it, it'll actually just say scripts. The first time you put it in, it puts in this really long thing. So let's put in our next. Let's make the code for this vehicle. The database is UMass training. Let's just make a copy of this, rename it, because our code's going to be very similar. So we're going to start oncoming vehicle 3.
Is it case sensitive?
It's not. I don't think it's case sensitive. But I always try to follow that regardless. Okay, so we're gonna. All we really have to do here is position on. Just change our things here. Oncoming vehicle 3. And change all our numbers, vehicle ID numbers, to 3. And again, I recommend that you keep a list of your vehicles that you're using and cross them off as you go, just so you don't accidentally reuse vehicles. Alright, so the path here needs to be become 3, oncoming path scenario 1, oncoming vehicle 3. Let's use our set velocity once instead of set desired velocity, so it's instantly going to be going 45. Let's just pick a speed, and we'll want it to be. We positioned that vehicle in the rightmost lane, so let's make it want to stay in the rightmost lane, and let's make it so it wants to turn right at the next intersection. So turn right. And we're done with that. Except for I've got one vehicle 28 there. So we're good to go. If you wanted the vehicle to be triggered by another, if you wanted, say, a vehicle, some other vehicle in the database to trigger this, what you would use is, rather than if entity is subject, you would say if entity, and then 3 equals signs. That means basically that's exclusive equals. Scenario vehicle, and let's say you have a vehicle 15 wandering around the database, and that's what you want to trigger it. Then that means that, and then just basically replace this here. That's what it would look like. Then it would be vehicle 15 would be the one triggering all this. And so if that was what your code looked like, then only vehicle 15 would trigger this code instead of your subject. But let's go back and undo all that. Okay. So it looks like we're done. So we'll save that, and we'll attach that to our sensor. Oncoming vehicle 3. Okay. So we have everything. We've pretty much finished that scenario. So now what we can do, we can test it. So let's save this database, and we'll sit and twiddle our thumbs while that saves. I guess while it's saving, I could talk about changes. So what we're going to do is we're going to publish this so that we can test it. If let's say you have a JavaScript error and you need to change something in the JavaScript, because the JavaScript is outside of the model, you don't have to republish it. So if you tweak your code, let's say you want the speed to be different, or you fix some kind of error that comes up, and it's only in the code, you don't have to republish your database. So that's done saving. Let's get this publishing. If you want to test your database, then what you want to do is here under Tile World. Actually, first this. So that's if that's saved, the one right next to it is publish. You click on that. Now the published, it's still a .wrl file, but it's the difference between the published model and the working model is that the WRL contains all the information regarding sensors, paths, embedded roadway information, whereas in the working model those are kind of external, those are separate. And it's a model that can be used. It's basically, you think of it as your compiled code. If you're a C programmer or something, publishing it is basically you're creating a compiled version of your database, whereas the unpublished version is basically where your working code is. So if you want to test it, here in the Tile World directory, so C databases Tile World, is a file called tileworld.wrl. And everybody in the lab understands that that is our test model. And you can overwrite that model as many times as you want. We have a way of, you can actually run the simulation here on the center channel using a copy of the simulator software that's contained there. I'll show you that. So if we save this as Tile World, in the Tile World directory, it'll say, do you want to overwrite it? You can say yes. It'll publish it. So while that's publishing, I'll continue with my discussion on changes. So if you wanted to change code and you don't have to republish, but let's say you wanted to add something or move a sensor, something within the database itself, you do have to republish the database. So for example, let's say our trigger point is off and the timing's not quite right and we want to move the trigger point slightly back, then we would do that. We would save and we'd have to republish again because you physically changed the model.
Should we make testing another lesson?
Yeah, we can do that. Because I think we've gotten well over a half hour here.
So that probably takes a lot of republishing to get the timing just right.
Yeah.
Fair in that scenario.
So okay, so let's go ahead and stop this. It's still publishing, but we'll show you the next lesson will be the there. It's done publishing. So the next lesson is going to be our actual testing of this. So see you at the next lesson.